So we all kind of want to learn how to get power. Numbers multiplied together. So for example, 2 times 2 times 2 times 2 is 2 to the 4. So when the same numbers are multiplied together, that is power, so that's 2 to the power of 4. Okay, there's a button on your calculator. I don't know if it's going to pick this up, but it's, draw it out, it looks like, it's just as a button. And it's there. But however, we can't just pop it in our calculator every time. So there are some rules about powers that we do need to know. Let me get rid of that. There are 3 kind of main ones, that they're not too bad. So we've got the first one, which is if you multiply powers, you add them. Multiply means you add them. So if we look at an example of this, we could have 2 to the 4 multiplied by 2 to the 2. So you get 2, and these powers, because they're multiplied, you then add them. So 4 plus 2, 2 to the 6, for example. If you had it with letters, so A to the 2 times A to the 7, because they're multiplied, you add them. 7 plus 2, A to the 9. Okay, so that's an example of that. It's just so much easier doing maths by looking at examples. I'm going to switch to maybe green. Then you've got the kind of, instead of multiply, divide, implies you subtract. Once you know one, you kind of know the other, because it's sort of just the inverse operations. So let's just do a quick example. 3 to the 8 divided by 3 to the 4, which can also be written like that. So you subtract them, so you get 3. 8 minus 4, subtract the powers, 3 to the 4. Okay, and then we've got the one that I call power, which just means a power to the power. So let's have a look at an example to find out what that actually means. So if I have 6 to the 2, so the power to a power, you just, should we write that in this bit, implies you multiply them. So you're going to get 6, 2 times 5, which is 6 to the 10. Okay, so they're kind of the 3 main ones that you should definitely know. Have anything to the power of 1, so x to the 1, that just equals x. So another example, without using x to make it a bit more obvious, so 3 to the 1 equals 3, 4 to the 1 equals 4. Check this on your calculator. It makes sense, so that's one to know. Another one is 1, so switching around to the anything is 1. So if I put numbers in there, 1 to the, I'm just going to write so many numbers, it's ridiculous, but just to make the point, that still equals 1. Because 1 to the 1 is 1, 1 squared is 1, 1 times 1 times 1 is 1, 1 times 1 times 1, etc. 1 times forever times 1 is still 1. Then we've got a weird one that x to the 0 equals 1. So any number to the 0 equals 1. So 5 to the 0 equals 1. 5,000 to the 0 equals 1. 4 to the 0 equals 1. So these are just good things to remember. They're a bit... These make a lot of sense. This one, a bit tricky to remember, but you might be able to remember it just because it is a bit funky. And the next one is if you have a fraction. So for example, 2/3 cubed. Because of the brackets around there, that means that you do it to both, so you do it to the top, same to the bottom. So let's just do another example. 5 over 7 to the 6 is the same to the top, same to the bottom. And if you think about it here, you've kind of got imaginary ones, because you know that 4 to the 1 is 4, so 5 to the 1 is still 5. And this is the same rule then as the power, so 5 to the 1 times 6 is 5. You don't really need to think about it like that, it just makes sense anyway. Negative power. Nobody wants negative power, it just sounds a bit weak. So, for example, this, the first thing when you see negative power is you just want to get rid of it. No one wants negative power, don't like negative power. And the way you do that is you turn it upside down. Kind of makes me want to write upside down. and then it becomes a, this might not even read, I don't know. So now, once you've turned it upside down, if that makes sense, it becomes a positive power. So the first thing you want to do when it's a negative power is, does anyone know the Jack Johnson song? Upside down, I'm gonna turn the whole thing. Just do that to make it positive. So that's negative power. Just think no one wants negative power. Turn it upside down, change it. We'll do an example in a minute. Another one is if you have x, silly pen, to the half, that's the same as square root. A third is the same as cubed root. So any fraction, so 1 over 12 is the same as the 12th root. So there's that one to remember. That's also kind of a trickier one, but you get used to it. So for example, 36, I'm making a mess now, to the half. Half is the same as square root, so you have root 36, which equals 6. And then we have the two-stage fractional power. This is the hardest, but quite like it when you know what you're doing. So, fractional powers, and you can have fractions to the fractional powers, which we'll look at in a question. So the first thing you do is you split into the root and the power, so the fraction bit at the bottom and then the top bit, which will then be the power. It's confusing to say, we'll just have to see. And then first you do the root, second you do the power. So let's look at an example of this. If I have 64 to the 2 over 3, so that's my fractional power, I want to split into root and power. So I'm going to split this 2/3 into its root and its power, so that'll be 64. So the root, which is the bottom bit, kind of like thinking of roots of a tree bottom bit, and the power, which is the 2. So I've just split that up. And then it says, following these instructions, root first, then power. So if I do the root first, I know that a third is a cubed, same as a cubed root, and then I do the power. So the cubed root of 64, cubed root of 64 squared, so the answer is 16. Okay, that is everything you need to know. Questions. If I have, first one, 2 to the negative 4, that's negative power, so the first thing I do is I turn it upside down and get rid of the negative power, so I make it positive. So I'm going to turn it upside down, 1 over 2 to the 4 now, because it's positive power. So that equals 1 over 2 times 2 times 2 times 2, 4, 8. So that's 1 over 16. Okay. Next question. 5 squared multiplied by 5 to the 4 over 5 to the 5. So first we'll do the multiplication. So let's just look at this part. So I have two powers that are multiplied together, so that was my first rule, so I add them. So I've got 5 to the 2 plus 4, added by 5 to the 5, which is 5 to the 6 over 5 to the 5. Now I have two powers divided, so that's the second rule, and I know I should subtract, so I have 5 to the 6 minus 5, which equals 5 to the 1, which is the same as 5. Okay. A wordy one, write 1,000, I'm just going to write as 1,000 as a power of 10. So we're going to have, so when you look at powers of 10, 10 to the 1 we know is 10. 10 squared is 10 times 10, which is 100. So it's got two. So I notice the pattern that when there's a 1, there's 1 0. When there's 2, there's 2 zeros. So when it's, oh, what am I doing? So when it's 3, it's 3 zeros. And I'm going to stop there because I know that's the answer. So this is the power. as a power of 10 is 10 to the 3. A to the 4 to the 5. This is the power rule. If you do want to try this before I just shout out the answer, just literally click pause just to test that you do know. So power means multiply, so we have A to the 4 times 5, which is A to the 20. Let's do another one. 27 to the 216 to the minus a third. Okay, this is as hard as it can get, and this isn't even too bad. So this is just an example of probably as hard as they can make it. So the first thing I need is a negative, so I need to turn it upside down and make it positive. So when I turn this upside down, I switch the numbers. So that's now upside down. And I've dealt with the negative, and that's now positive. So that's all you have to do. Get a negative, just switch it around. And then I know from the rule before, if I have a fraction to a power, you have to do the same to the top as the bottom. So that's that. So yeah, do the power to the top and the bottom. And I know from a previous rule, this one's using so many rules, I love this example. To the third is the same as cubed root. (27). So that is 6 divided by 3, which is 2. Okay, so just take it step by step, don't get too confused, get as far as you can, you're going to get marks. Anyway, q to the 4, p to the minus 3 multiplied by 3, q to the 6, p to the 4. So this is a multiply one, so we know from the first one that when you multiply you add. So numbers are just numbers, same as usual, 5 times 2 is 15. Now we've got the q's here. So I've got q to the 4 multiplied by q to the 6. So don't get too confused, that's not multiplying, that's adding. Like when there's a lot going on, it's hard to remember all of this. So 6 plus 4 is 10. Then we have to deal with the p's. This is basically a rubber at this point. So you've got minus 3 multiplied by p to the 4. So it's multiplying, so we're adding. So minus 3 plus 4, which is p to the 1, but we don't need that one there, because p to the 1 is the same as p. Okay, let's look at 4c squared d squared. So when it's in brackets, you have to do it to every single term. So if this is the same as 4 squared multiplied by c squared multiplied by d squared. It's easier if you break it down like that. 4 squared, 16, multiplied by, this is now power, so power is multiplying the powers, so power so many times now. So you got c, 2 times 2 is 4, and then d squared, and you can just write that as them together, because got invisible multiplication signs in there. Okay, and then let's do one more. A cubed b to the 5 divided by ab squared. Okay, so this is divisions. This was our second rule, and we know we have to subtract. So we're going to have a, we've got 3, and then here we have invisible 1. So 3 minus 1, which is 2. Then we've got b, 5, take away 2 is 3. There we go.